Okay, now today, students, we are going to start fifth chapter, that is continuity and differentiability of your textbook 1, part 1. Okay, we have completed chapter 2, that is inverse trigonometric function. I had sent you some short sums as well as PDF of that miscellaneous exercise. If you have any doubt, you can send doubts to me. If the doubts are many or common, then I will record that video also and send it to you. Okay, so now we are going to start with continuity and differentiability. From that, first we will start with continuity. Okay, so what do you mean by continuity? Continuity means continuous. Okay, yes, continuous, right. So geometrically, if I say that what is continuous function, then you can say that if the graph of any function keeps on going without any break, then you say that it is continuous. Okay, geometrically we can say that at particular point also the function is continuous when at that point also the graph continues, okay, without any break, that is there is no break at that point also, then you can say that it is continuous at that point also. So now we will start with this basic thing. A function f at x is said to be continuous at a point x equals to a, that any point x equals to a, if first condition f at a exists. F at a exists means what? That is, f at a is finite, that is, it is finite, it is definite, and it is real. So this is necessary that the function at that point should exist, that is, f at a should exist. Also, second thing, limit x tends to a, f at x exists. So this is also essential that limit at this point also must exist. Okay, and third and most important thing is that limit x tends to f at x should be equals to f at a. That means these first two must exist independently and they should be equal. This is the third condition. Okay, if these three conditions are satisfied, then you can say that any function f at x is continuous at that point x equals to a. Okay, so now I am going to explain you that how to check. It is a rule to check the continuity of any function at particular point. Say suppose you are given any function, say f at x, and you are given and you have to check the continuity at x equals to c. Okay, so first of all, what you have to do is, your first step will be, you have to find you have to take x equals to c and find f at c. Okay, first of all you have to do this. Then second step, you have to check that whether limit x tends to that point exists or not. Okay, so for that what you have to do, first of all you have to find left hand limit. You have to find left hand limit. Now you will say, what is left hand limit or LHL? Now we have to check for this left hand limit. What is LHL? I will explain you over here. Now say suppose there is any graph is there like this, any curve is there. Okay, suppose we have to check at this point. So LHL means at this part and RHL means at this part. Okay, greater than and lesser than. So LHL means lesser than. Okay, so that is, we have to check for LHL, we have to check, that is for x less than c. We have to check for x less than c. Symbolically we write like this: limit x tends to c minus f at x. This is what we have to find. So for finding this, what we have to do? We have to replace, you have to take x is equals to c minus h. This is what we have to take. Now if we take c minus h, then, or you can say c minus h, when x tends to c minus, then h tends to 0. If I place x equals to c over here, then what I will get? H will come over here, c will go over there, so c minus c, that will be 0. So h tends to 0. So LHL will be limit x tends to c minus f at x, that is equals to limit h tends to 0 f at c minus h. Now I have to find this value. Okay, similarly I have to find RHL, that is right hand limit, that is RHL, in the same way. Okay, so what I have to do for that? Okay, for what I have to do for that? For that, we have to take, when we take x tends to c plus, okay, x tends to c plus, then h tends to 0. That means you have to take x is equals to c plus h. You have to take x is equals to c plus h. If you take x is equals to c plus h, then when x tends to c plus, then h tends to 0. So your RHN will be equals to limit x tends to c plus f at x, which will be equals to limit h tends to 0 f of c plus h. Here h tends to 0, f of c minus h here. Okay, now after finding all these three, you should get limit x tends to c minus f at x is equals to limit x tends to c plus f at x is equals to f at c. If you get all these three equal, then you can say that this limit is continuous at x equals to c. This limit is continuous at x equals to c. Okay.